Let's look at refractive index again, but this time we're going to do a little bit more complicated example. In this case, we're going to be given the angle of incidence, and we're going to be given the refractive index, and we're going to have to calculate, well, what's the angle of refraction going to be? So, in this problem, we're told that the angle of incidence is 65 degrees. Right, that's quite a steep angle of incidence. We're also told that the angle of, we're not told what the angle of refraction is. We're told that the refractive index of the material is 1.5. Again, no units for refractive index. Okay, so how do we do this problem? Well, we start with our formula. Now, first we should maybe consider a diagram. So here we have our interface. We've got our incident ray coming in at quite a steep angle. We've got a normal in here, like this. Here's our normal. It's not a real line. It's something we just imagine that's there. Then we've got in here, this is 65 degrees. Now, over here we've got this, whatever material this is here, has a refractive index of n equals 1.5, right? N equals 1.5. And so our refracted ray will do this. And we're going to have some angle in here, or. Now remember always, the angles are from the normal to the rays. So we're trying to calculate what or is. It's not given to us in the problem. So we start with our formula again. Sine I is equal to, or sine I over sine or is equal to n. And let's fill in the different values that we're given. So we're given the value of I, so we put that in. Sine of 65 degrees over, we don't have the value of or, so we can just do sine of or, is equal to, and n is 1.5. So I now have to rearrange this so that I can try and get sine or on its own. So how do you do that? Well, firstly, I'll multiply across by sine or to get rid of the fraction over here. So I'll end up with sine of 65 degrees is equal to 1.5 times sine of or. Now, I want sine of or on its own. So, oh sorry, I should have said here, you can also cross multiply here, and you would have, if you consider 1.5 over 1, so you'd have sine of or by 1.5, and then sine of 65 by 1, and you'll end up with the same thing. But here we multiplied across by sine of or, it's the same thing. So sine of 65, now I want sine of or on its own, and it's multiplied by 1.5. So I have to divide this side by 1.5 to get rid of it. And that means because I got an equal sign here, I have to divide this side by 1.5 as well. So what I'll end up with is sine of 65 degrees over 1.5 is equal to the sine of or. Now I'll flip these around so that I'll just get sine of or on the left hand side. So I get sine of or equals, now I better do it in steps, sine of 65 degrees over 1.5. And now if I put this into a calculator, I can get what this value is. So how do I put it all into the calculator in one go? Well, I type sine, I put 65 degrees in there, then I have to close the bracket, then I divide by 1.5. So that's what's on my top line in my calculator. I hit equals, and I get this value. I get 0.6042, right? 0.6042. Now that's for sine of or. So in order to get rid of this sine, now this is a tricky bit, some students find this difficult. I want to get rid of this sine. Sine is acting on or here. So to get rid of that, I would need the inverse of that on this side. So I would do sine inverse of the sine of or, and the sine inverse and the sine would sort of cancel each other out to a certain extent, and I would end up with or. But because I've done it on this side, I also have to do it on this side, so I get sine inverse of 0.6042. I can do that in steps if you want to see it. I'd have to do sine inverse of, and then I would do sine of or, like that. And this sine inverse of sine is like doing 1 over x times x. It just cancels away. And then over here, I would have to do the same thing. I would have to do sine inverse of, and I would put 0.6042 in there. So you can see I've done sine inverse of what was on this side and sine inverse of what was on this side. And what happens is this kind of goes away, and what you end up with is or is equal to sine inverse of 0.6042. And as a result, if you do that on a calculator, now let's see how to do that on this calculator. Let's clear the screen first. You would have to do sine inverse. So to do sine inverse, you have to hit shift, and then sine inverse is shift and sine will give you sine inverse, and it comes up on the screen. Sine inverse, and you have to then punch in the numbers 0.6042. Now to get the realistic, because I had 0.6042 up here as my, and it had all of the rest of the decimal places to a higher accuracy there last time, I could just hit answer here, this answer button, and it'll put the last answer that I got in there as well. That's actually a little bit more accurate, so you won't get as much of a rounding error. But for now, this will do. It would also do for exams. So if you hit equals, now what comes out of this is in degrees. So my or now is 37 point, and we'll say 17 degrees. 2 decimal places is enough. And now I have my angle of refraction as 37.17 degrees.